When a home is to be rewired, the laws governing rewiring and the removal of old wiring vary from state to state and municipality to municipality. The NEC, which stands for National Electrical Code, provides general guidelines and standards for electrical wiring and safety, but it does not specifically mandate the removal of old wiring during rewiring projects. Most states and towns have their own building codes that adopt the NEC and may include additional requirements. These codes may specify whether old wiring must be removed or can be left in place under certain conditions. While laws may differ, common practices include a focus on safety first. Old wiring should always be inspected by a qualified electrician to assess its condition and potential hazards. It is generally recommended to remove old wiring, especially if it is damaged, deteriorated, or presents a safety risk. Some codes may allow old wiring to be left in place if it is still in good condition, not interfering with the new installation, and capped or isolated properly. If old wiring is left in place, the following considerations should be made. The old wiring should be properly capped with wire connectors and insulated with tape to prevent accidental contact or arcing. The old wires should be clearly labeled as inactive to avoid confusion during future inspections or repairs. The decision to leave old wiring should be recorded in the electrical inspection report and any permits associated with the rewiring project. It is always advisable to consult with a qualified electrician and check with your local building department to determine the specific regulations in your area. When undertaking a rewiring project, several key electrical concepts and components come into play. Firstly, understanding voltage is essential. In residential settings, common voltages are 120 volts and 240 volts. The 120 volts is typically used for lighting in small appliances, while 240 volts is used for larger appliances like stoves, dryers, and air conditioners. Secondly, amperage is a measure of electrical current. The amperage rating of a circuit breaker or fuse determines how much current a circuit can safely handle. For example, a 15 amp circuit breaker is commonly used for lighting circuits, while a 20 amp circuit breaker is used for receptacle circuits in kitchens and bathrooms. Thirdly, conductors are the wires that carry electrical current. Common types of conductors include copper and aluminum. Copper is generally preferred due to its high conductivity and resistance to corrosion. The size of the conductor is determined by the amperage it needs to carry. NEC Table 310.15b16 specifies the allowable ampacities of insulated conductors. Fourthly, insulation is the non-conductive material that surrounds the conductors. Common types of insulation include thermoplastic high heat-resistant nylon-coated, known as THHN, and thermoplastic high water-resistant nylon-coated, known as THWN. The type of insulation used depends on the application and the environment. Fifthly, grounding is a critical safety measure. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Ground wires are typically green or bare copper. Sixthly, overcurrent protection devices such as circuit breakers and fuses protect electrical circuits from overloads and short circuits. When the current exceeds the rating of the device, it trips or blows, interrupting the flow of electricity. Seventhly, electrical boxes are used to house electrical connections. They are typically made of metal or plastic. Eighthly, receptacles, also known as outlets, are the points where electrical power is accessed. They are typically rated for 15 amps or 20 amps. Ninthly, switches are used to control the flow of electricity to lights and other devices. They are typically rated for 15 amps or 20 amps. Tenthly, lighting fixtures are devices that produce light. They come in a variety of types, including incandescent, fluorescent, and LED. Finally, the NEC is a comprehensive set of standards for electrical wiring and safety. It is updated every 3 years. Local building codes often adopt the NEC, with or without amendments. When rewiring a home, it is essential to follow the NEC and local building codes to ensure electrical safety. Always consult with a qualified electrician to ensure that the work is done correctly and safely. Proper planning is essential for a successful rewiring project. Firstly, you need to assess the existing electrical system. This involves inspecting the wiring, outlets, switches, and electrical panel to determine their condition and capacity. Secondly, you must determine the electrical needs of the home. This includes calculating the total load of all appliances, lighting, and other electrical devices. Thirdly, you need to develop a wiring plan. This plan should show the location of all outlets, switches, lighting fixtures, and other electrical devices. Fourthly, you need to obtain the necessary permits. Most jurisdictions require permits for electrical work. Fifthly, you need to gather the necessary materials. This includes wiring, outlets, switches, lighting fixtures, electrical boxes, circuit breakers, and other electrical components. Sixthly, you should prepare the work area. This involves disconnecting the power to the circuits being worked on and removing any obstacles that may be in the way. Seventhly, you need to install the new wiring. This involves running the wires through the walls, ceilings, and floors and connecting them to the outlets, switches, and lighting fixtures. Eighthly, you should install the electrical boxes. The boxes should be securely mounted to the framing. Ninthly, you need to install the circuit breakers. The circuit breakers should be sized according to the amperage of the circuits. Tenthly, you must connect the wiring to the electrical panel. The wiring should be connected according to the NEC and local building codes. Finally, you should test the new wiring. This involves using a multimeter to check the voltage and continuity of the circuits. The NEC provides detailed guidelines for wiring methods. Firstly, non-metallic sheath cable, commonly known as Romex, is a common type of wiring used in residential buildings. It consists of two or more insulated conductors enclosed in a non-metallic sheath. Secondly, metallic sheath cable, commonly known as BX or armored cable, consists of insulated conductors enclosed in a flexible metal sheath. Thirdly, electrical metallic tubing, commonly known as EMT, is a thin-walled metal conduit used to protect conductors. Fourthly, rigid metal conduit, also known as RMC, is a thick-walled metal conduit used to protect conductors in harsh environments. Fifthly, liquid-type flexible metal conduit, commonly known as LFMC, is a flexible metal conduit used to protect conductors in wet locations. The NEC also specifies the requirements for grounding and bonding. Grounding is the connection of electrical equipment to the earth. Bonding is the connection of metal parts of electrical equipment to each other. Grounding and bonding are essential for safety because they provide a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing an electrical shock. The NEC also provides requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from overloads and short circuits. When the current exceeds the ratio of the device, it trips or blows, interrupting the flow of electricity. The NEC also provides requirements for wiring devices. Wiring devices include outlets, switches, and lighting fixtures. The NEC specifies the type of wiring devices that can be used in different locations and the methods for installing them. Common electrical problems encountered during rewiring include open circuits, short circuits, ground faults, and overloaded circuits. An open circuit is a break in the circuit that prevents current from flowing. A short circuit is an unintended connection between two conductors that causes a large current to flow. A ground fault is an unintended connection between a conductor and ground that causes current to flow through the ground wire. An overloaded circuit is a circuit that is carrying more current than it is designed to handle. Troubleshooting electrical problems requires the use of various tools, including a multimeter, a circuit tester, and a wire tracer. A multimeter is used to measure voltage, current, and resistance. A circuit tester is used to check for the presence of voltage. A wire tracer is used to locate wires behind walls and ceilings. Electrical safety is paramount when rewiring a home. Firstly, always disconnect the power to the circuits being worked on before starting any work. Secondly, use insulated tools to prevent electrical shock. Thirdly, wear safety glasses to protect your eyes. Fourthly, never work in wet conditions. Fifthly, follow the NEC and local building codes. Finally, if you are not comfortable working with electricity, hire a qualified electrician. Regular electrical maintenance can prevent problems and extend the life of your electrical system. Firstly, inspect your wiring, outlets, and switches regularly for signs of damage. Secondly, replace any damaged wiring, outlets, or switches immediately. Thirdly, test your ground fault circuit interrupters, known as GFCIs, regularly to ensure that they are working properly. Fourthly, avoid overloading circuits. Fifthly, have your electrical system inspected by a qualified electrician every few years. Energy efficiency is an important consideration when rewiring a home. Firstly, use energy-efficient lighting fixtures, such as LED lights. Secondly, install dimmers to control the brightness of your lights. Thirdly, use energy-efficient appliances. Fourthly, insulate your walls and ceilings to reduce energy loss. Fifthly, seal any air leaks around windows and doors. Smart home technology can enhance your home's electrical system. Firstly, install smart outlets and switches that can be controlled remotely. Secondly, use smart lighting systems that can be programmed to turn on and off automatically. Thirdly, install a smart thermostat to control your home's temperature. Fourthly, use a smart home hub to control all of your smart home devices. Rewiring a home can be a complex and challenging project. However, by following the NEC and local building codes, and by taking the necessary safety precautions, you can ensure that the job is done correctly and safely. Always consult with a qualified electrician if you have any questions or concerns. When dealing with aluminum wiring, special considerations are necessary due to its tendency to corrode and loosen connections. Firstly, use COALR-rated connectors, which are specifically designed for use with aluminum wiring. Secondly, apply an antioxidant compound to the aluminum wiring before making connections. Thirdly, tighten the connections securely, but do not over-tighten them. Fourthly, inspect the connections regularly for signs of corrosion or loosening. Fifthly, consider replacing aluminum wiring with copper wiring for added safety and reliability. In older homes, asbestos may be present in the insulation of wiring. Asbestos is a hazardous material that can cause lung cancer and other respiratory illnesses. If you suspect that asbestos is present, do not disturb the wiring. Contact a qualified asbestos abatement contractor to remove the asbestos safely. When working in damp or wet locations, special precautions are necessary to prevent electrical shock. Firstly, use ground fault circuit interrupters, known as GFCIs, to protect circuits in these locations. Secondly, use weatherproof outlets and switches. Thirdly, use liquid-tight conduit to protect wiring. Fourthly, never work in standing water. When working with low-voltage wiring, such as telephone cable and data wiring, different codes and standards apply. Firstly, follow the TIA/EIA standards for low-voltage wiring. Secondly, use Category 5E or Category 6 cable for data wiring. Thirdly, use coaxial cable for cable television wiring. Fourthly, use telephone wire for telephone wiring. Fifthly, keep low voltage wiring separate from high voltage wiring. When adding new circuits to an existing electrical panel, it is important to ensure that the panel has enough capacity to handle the additional load. Firstly, calculate the total load of all circuits in the panel. Secondly, determine the panel's ampacity rating. Thirdly, if the total load exceeds the panel's ampacity rating, you will need to upgrade the panel. Fourthly, when adding new circuits, use the correct size circuit breakers and wiring. When replacing an electrical panel, it is important to follow the NEC and local building codes. Firstly, disconnect the power to the panel. Secondly, remove the old panel. Thirdly, install the new panel. Fourthly, connect the wiring to the new panel. Fifthly, test the new panel. Sixthly, have the work inspected by a qualified electrical inspector. Solar panels generate direct current, known as DC electricity. This electricity must be converted to alternating current, known as AC electricity, before it can be used in a home. This is done using an inverter. Solar panels must be installed according to the NEC and local building codes. Wind turbines generate alternating current known as AC electricity. Wind turbines must be installed according to the NEC and local building codes. Generators can be used to provide backup power during a power outage. Generators must be installed according to the NEC and local building codes. Surge protectors protect electrical equipment from voltage spikes. Surge protectors should be installed at the electrical panel and at individual outlets. Arc fault circuit interrupters, known as SIs, protect against electrical fires caused by arcing faults. SIs are required in many areas of the home. Electrical inspections are performed by qualified electrical inspectors to ensure that electrical work is done according to the NEC and local building codes. Electrical permits are required for most electrical work. Always obtain the necessary permits before starting any electrical work. Hiring a qualified electrician is essential for any electrical work. A qualified electrician has the knowledge and experience to do the job correctly and safely. They will also be familiar with the NEC and local building codes. Electrical safety is everyone's responsibility. By following the NEC and local building codes, and by taking the necessary safety precautions, you can help to prevent electrical accidents.